while some classes can extend other classes to create the subclass superclass relationship, for interfaces, we're going to use the keyword implements. And so if a class implements an interface, then it is expected to have all of the methods that the interface contains. And unlike classes where one class can only extend one other class, any class can extend any number of interfaces. So you can extend to no interfaces if you don't want to, or you can extend 1,000,000. There is no limit here. Because interfaces only contain kind of the outline of what methods and functions a class should have, you can't have objects of type interface. So for example, if I had like the list interface, I can't have list objects because there would be no list constructor to initialize these list objects. But rather, I could have type array list objects, or I could have typed linked list options, or a bunch of other types of list objects, but without having like using the keyword new list, because if list is the interface, there wouldn't be no constructor associated with it. So kind of to best demonstrate it, we can use our classic example where we have different type of people and different type of animals. So usually in our webinars, we'll have you create like the person class, and then there are different things that can extend upon this, such as like we can have a doctor who's a type of person, a farmer who's a type of person, as well as we can have the animal class with subclasses dog and cat. And just notice how that doctor and the farmer only extend one superclass. In this case, it's person. And the same applies for our dog and our cat. But with interfaces, for example, you can extend a class and have an interface. So imagine we have the field worker interface. So in our scenario here, both farmers and dogs can work in the field. And if you work in the field, you have certain responsibilities that people from different classes might not have. Like, for example, let's say all field workers are responsible for taking care of animals in some sort. So like cats aren't. Can anyone else hear me?
I can hear you, Duck.
Okay. Is your maybe check to see if your volume's up, if that helps. Okay. So if, oops, sorry. Your volume. So let me pull this back up. And I guess Hannah can try to troubleshoot there. So yeah, so for example, doctors don't have to work in the field, cats don't have to work in the field, but farmers and dogs do. And how do we kind of group these objects that already belong to existing classes with a new kind of requirements that they're also supposed to have? That's one reason why we would use interfaces. So for example, if we wanted to ensure that both farmers and dogs had like some field worker methods, such as take care of animals, we can have them implement the field worker interface. So how that would look is we would have the interface field worker, which would have the list of methods that all field workers are expected to have. So for example, the care for animals method, but it doesn't, the interface itself doesn't implement the method. It just, because it ends with a semicolon instead of kind of a bracket, it just says that the method has to be implemented, as opposed to showing you how to implement the method itself. So that, therefore, if the farmer and the dog were going to implement the field worker class, they could implement the care for animals method in different ways. So for example, a farmer might be responsible for feeding animals, while the dog might be responsible for herding sheep. And they both have the same function in which they care for animals without having the same, how the method should be written, kind of like enumerated out. Does that make sense so far? I know most of you said you've done some work with interfaces in the past, so hopefully this is kind of a review. If you have any questions, if you feel free to type them in the group chat function, or if you don't have any questions, type that as well, just so we know. Okay, I'll wait another minute or two in case anyone is still typing out questions. Okay, if you're still typing out any questions, feel free to keep working on that. The next thing we're going to go over today is the most common interface you'll see on the AP exam, and that's the list interface. And we're just going to walk through kind of what the list interface is, what methods it includes, so you can be familiar with it if you see it on any free response or multiple choice question. So how interfaces are kind of set up are with several keywords. The first is all interfaces will be public, so you'll start off with that keyword here, as well as the keyword interface and then the name of your interface. So this is similar to how classes are set up with the public class and then the name of the class, except for in our case it's an interface. All of the methods included in an interface are going to end with a semicolon, and that's just saying that all classes that extend this interface or that implement this interface will have to specify how these classes are written. Interfaces usually won't have any instance variables, again, because this is just saying the methods that classes need to implement, as opposed to stating exactly how these methods should be implemented. So for example, for the list interface, any class that implements the list interface will need a size function that will return the size of the list, an add function that will add an element to the end of the list, and then return true or false whether or not it's been added or not. We also have the add, where you can specify an index of that you want a certain object to be added, as well as the get, which returns the object at a specific index. Set allows you to change whatever's at a certain index to a new object, and then it will return the old object that used to be there. And then remove, which allows you to take away something at a certain index. So on the AP exam, you will be asked to know all 6 of these methods. For what they'll do most of the time is they won't test you about these in the multiple choice directly, but maybe they'll call one of them and ask you what it returns. But what the main part that you'll be tested with is usually in the free response, they'll ask you to do some kind of computation with lists, and you'll need to call these methods. So it's really helpful that you understand what these 6 are and what they do, because these are the 6 they'll be asking you to pull from in your knowledge base when they ask you to call or implement any list functions on the free response portion of the exam. So if we look into how different lists implement the list interface, we can take the example of the array list class. And so what it does is, for the ArrayList class, it's going to have its own constructor, and it can have its own methods, but it must have the 6 methods that the list interface has. So, for example, one way that the ArrayList class might implement size is by returning its instance variable list.length. And because the ArrayList class will have its own instance variables and its own methods in addition to just the ones that the that the list interface has, it can decide how it wants to implement the functions that the list interface has. And so this ... down here represents all other 5 methods that are included in the list interface, which would also need to go into your ArrayList class. Does anyone have any questions about how interfaces work? There are all other interface methods that might be found on the AP. They usually will give you an example of. So the list interface is kind of the main one that the AP will expect you to know, and they won't provide you kind of any documentation for. So if they do implement another interface, did you see the subtract method? Was that from a practice problem or from a past AP maybe, Nathaniel? Yeah, so if they do implement any other interfaces, usually they'll give you some sort of documentation or background on it for. Usually the list interface is the only one where they'll expect you to know it from memory and use some of these methods in your implementations for some of the other free response questions. Does that answer your question? Yeah, no problem. Does anyone else have any other questions about either interfaces in general, when they're used, why they're used, or the list interface in the AP test expectations? I think as long as you know the list interface and how interfaces are used in general, you should be okay. The AP test is not going to quiz you too much on specific interfaces outside of the list interface. Another good one to know is probably the comparable interface, but even if they asked you to, they would let you know that they were specifically referencing the compare to method, and they would give you examples of how that should look like. So you won't have to have that memorized. So as to which ones you should have memorized, definitely the list interface. But as long as you know how to implement your own interface and kind of what interfaces do, you should be okay for the exam. Any other questions? If not, then I'm going to pass it over to Hannah, who's going to walk us through some practice problems for tonight and then answer some more questions.
Hey guys, so now we're going to do some practice problems. So I just put a link to tonight's questions in the chat. So we're going to give you guys 20 minutes to do these and then we'll go over them together. Hi guys, even if you have not finished up, please try to submit your answers within the next minute or so, and we'll start going over them at 8:45. Okay, guys, we're going to start going over the answers to the questions now. Let me share my screen with you guys. Okay, so the first question asked you guys to match the following words to some phrases. So the first one was actually kind of a trick question. Class doesn't really go with any of these. And then for the second one, subclass. So whenever you make a subclass of another class, you always use the keyword extends. And classes can only have one parent class, but a class can have an unlimited amount of subclasses. So that was the correct answer for that one. And then for interface, Jack talked about this earlier. When you want a class to have an interface, you use the keyword implements. And a class can have an unlimited amount of interfaces. So this is something to remember that some of you guys answered incorrectly, that a class can implement as many interfaces as it wants. Do you guys have any questions about this first part of the practice? Okay, if not, then we're going to move on to the second part. So the second question asked you guys to write some code for employee classes that all implement the paid interface. So I'm going to show you guys how I solved this problem. And this is not the only way, since as Jack talked about earlier, an interface doesn't actually have any implementation of the code. We left this question a little bit open-ended, so you could have implemented the pay employee method a little bit differently for each class. So I'm going to show you guys how I did it now. So in Eclipse, I just have the paid interface written out here with our pay employee method. And then here is my hourly employee class. So it's very important that if we want it to have the paid interface, that we have our keyword implements paid. And then here I have my constructor. And so for my constructor, I wanted to take in the hourly rate that our hourly employee would be paid. And I also chose to have our hourly employee have a name. You could have omitted this part. You don't have to have a name, but I just thought that would be easy to show you guys for our example later if each employee had their own name. So then in my constructor, I'm setting my hourly rate instance variable equal to h. And then I also have a total earnings variable that's going to keep track of this employee's earnings overall. And we're just going to set that equal to 0 to start with. And then I'm setting the name equal to n. Then since our hourly employee implements the paid interface, that means that it must have all of the methods that are in the paid interface. And so our paid interface only had one method, which is the pay employee method. So that means that our hourly employee class must have this method included. So for our hourly employee, we gave you guys the description that our employee would be paid a certain rate each hour. So how I chose to implement this method is that most employees work an 8-hour day. So each time that I call this method pay employee, our total earnings are going to have an addition of our hourly rate times 8, just to account for how much this employee would probably earning per day. And then since in our method, we have int inside of our declaration, we need to return an integer. And so I'm just going to return total earnings from this method. And so this is how I chose to implement it, but some of you guys did it a little bit differently. One person had in their constructor for the hourly employee, they had a specific number of hours variable that this employee would work per day. And so then in their pay employee method, they would have the total earnings add the hourly rate times that number of hours. And that is also a totally acceptable answer. So does anybody have any questions about my hourly employee class? Okay, if not, then I'm going to move on to the salary employee. So just like the hourly employee, our salary employee has the paid interface. So we're going to use the keyword implements here. And then for my salary employee constructor, I'm going to have it take in an integer s, and this is going to represent the salary rate of our employee, so how much this employee gets paid per month, as was written in the problem description. And then just like the hourly employee, I'm also going to take in a string that I'm going to use to name the employee. And once again, you did not have to include this, I just chose to. And then we're also going to have a total earnings variable that is going to keep track of the total amount that this employee has earned. Then, since the salary employee implements the paid interface, we need to once again have a pay employee method. But how our salary employee is going to get paid is different from our hourly employee. So for our salary employee, we're just going to have the total earnings. We're going to have the salaried rate get added to our total earnings, versus how for our hourly employee, we had our hourly rate times the total number of hours. And then we're going to return the total earnings of that employee. Does anybody have any questions about how I implemented this class? Okay, if not, then let's move on to our contract employee class. So just like our other two classes, our contract employee is implementing the paid interface. So we use the keyword implements. For our constructor, all that we're going to have is a string n that is going to represent the name of our contract employee. Because unlike the other two employees, where their salaries were dependent upon a variable that our user had to pass in, our contract employee is always going to get paid $500. So we don't need to take in anything in the constructor because every single contract employee is going to get paid the exact same amount. So then I'm also going to set our total earnings equal to 0. And then for our pay employee method, like I said, every single time our contract employee gets paid, it's going to be $500. So we're just going to add $500 to our total earnings variable each time. Do you guys have any questions about this class? Yeah, so we didn't specifically give you guys these two variables. And like I said, the name is completely optional. I just did that so I could show you guys an example a little bit later on. You did not need this name variable at all. But this total earnings variable, you kind of just had to interpret in the question. Since it's an employee class, each employee needs to get paid, and you would probably want to keep track of how much this employee is being paid. And so since we want to keep track of how much the employee is being paid, I had a total earnings variable that's going to keep track of that. And so that's just kind of something that you should interpret from the question. But technically, I guess you don't really need to have either of these. But if you were just thinking about implementing this class in real life, it wouldn't really help us at all to just have a class where you have a pay employee method that is going to add $500 to our employee, but then not do anything with it. Because if we're not keeping track of every time that we pay this employee, then it doesn't really have any use for us in real life. Does that make sense? Okay, cool. Yeah, on the AP tests, they will be, if they want you to for sure have something specific in your code, they will definitely mention it to make sure that you know that. So like, for example, if this was an AP problem, you wouldn't get any points off for not having this name variable. That is just completely something that I decided to make up on my own. And you also probably, depending on what the question was, would also not get off points for this because they didn't specifically ask you to have a total earnings or a total earnings variable. Where this would be a problem is if they asked you later in another question to maybe figure out how much an employee has earned over time, then you would want to have a variable that keeps track of that. But if the question doesn't specifically ask you for it, then you don't necessarily need to have it. Okay, so then let's move on to our next question, which was asking you to write a pay employees method. So I have the method written out here. So one cool thing that you can do with interfaces is that even though all of these employees are different classes, since they all implement the paid interface, we can actually make an array of objects that implement the same interface. So we can have an array of things that implement paid. And so what we're going to do for this method is we're going to take in an array that has objects that all implement the paid interface. And what we want to do is for each object that is in this array, we want to pay that employee. And so I just have a simple for loop that we're going to start at 0. We're going to go through the whole length of the array so that we reach each object in it. And for every single object in the array, we know that since they all implement the paid interface, they're all going to have this pay employee method. Because when you have an interface and you say that a class implements a certain interface, it basically acts as a contract that says, since you're implementing this interface, this class is guaranteed to have the methods that are in this interface. And so we know that every single object in this array is going to have a pay employee method. So for each of the objects, we're going to go through and we're going to pay employee. And so then I just wrote out a main method so you guys could see. And that's the reason why I had our string name in each of the classes so I could show you guys easier in this main method. So I just created 3 employees. Each of them are different types of employees. And then we're going to add them all to our employees array. We're going to call our pay employees method on them. And then once you do that, if you look at the first 3 lines of our output, we can see that each employee has different earnings based upon what their pay employee method was. So Jack was an hourly employee, so her pay is going to be 30 times 8 for the 8 hours a day that she worked. Hannah's total earnings are going to be 1,000 because our salary employee method for pay employee is just adding our salaried rate, which is 1,000, to her total salary, total earnings. And then for 7, her total earnings are just going to be 500 because like we wrote out, each time you pay a contract employee, they're always going to be paid $500. And then just to make this a little bit clearer, I ran the pay employees method again and then looped through each of the objects in our array one more time, just so you could see them get paid one more time in this output. So does this make sense to you guys? Or do you have any other questions before we go? So we did not have a specific length that employees had to be in the question because it just asked you to implement this method. And so that's why I used a for loop that just went to less than employees.length, because we're not sure exactly what the length of this array is going to be every time. But in this specific example that I used, I made employees a variable of 3 objects. Does that answer your question? Okay, great. So if no one has any other questions, that is it for our webinar tonight. I wanted to announce to you guys that we have another in-person meeting coming up on May 13th. And so here is the link to that RSVP form. We are also going to be sending out an email about that either tonight or tomorrow. And so this is just going to be a last chance for you guys to ask questions and do some practice before the exam. And Jack also just posted the link for you guys to sign up for one-on-one tutoring if you have any last questions before the exam. Thanks for that, Jack. And yeah, like she said, feel free to let us know anytime on GroupMe or through email if you guys have any questions. But yeah, that is it for tonight. We hope that you guys have a great week. We'll see you soon. Bye.